Hi there and welcome to Discordant Bays with Mr. Mercer. Now, in this clip, rather like with concordant bays, I'll be quite brief. The first place to start is with the term discordant bay. The rock layers in a discordant bay example run in discord or disagreement with the line of the coastline. So they tend to be at 90 degrees or right angles to the sea. There are three different types of rock. You can probably score a mark by pointing out that some are harder and some are softer, but really it's better if you know the names of some likely rocks. Along the South England coastline, you're likely to find chalks and clays, and possibly limestones. Limestone is harder, clay is softer, and chalk, though not the hardest of rocks, is harder than the clay. After this point, you really need to focus your revision on the processes involved, the processes of erosion and the processes of weathering. So let's get started. First of all, the sea attacks the soft rock much more readily or quickly than it does the harder rock. This is called differential erosion. As you can see, the softer rock has been eroded away more. At this point, I would make sure to point out that abrasion, which is when rocks thrown against the soft rock by the waves wear away the clay, cause a bay to be formed. It's important that you're able to go into that level of detail with your processes. Another example would be hydraulic action, which is when bubbles of gas are forced into weaknesses in the rock and break it apart, wear away the clay. Again, the full length and depth of detail necessary is what's at stake. The other processes to mention here alongside abrasion and hydraulic action would be wave pounding. Attrition is not so useful to you because it's merely the rounding and breaking up of rocks within the water. However, never forget the weathering processes. You could talk about biological weathering, where plants grow roots down into weaknesses in the rock and break it apart. Or freeze-thaw, where water seeps into cracks in the rock, freezes, expands and shatters it apart. And also processes such as salt crystallization, where saturated rock causes salt crystals to form within it. As these salt crystals grow, they break the rock apart from within. These are all excellent opportunities to score marks. In any case, the soft rock has been eroded back to form a clear bay shape. The harder rocks to either side are also eroded, just more slowly, coming back again to that term differential erosion. At this point in your diagram, all you would need to do is label which is which. The remaining harder rock is eroded and weathered into a headland, and a discordant bay is formed in between. Remember, it's useful to have a case study example, and in this instance I would refer to Swanage Bay as a very clear example of a discordant bay. If you've got any questions about this, come and find me in class, but otherwise I hope this was helpful. Thanks for listening, bye.